Let's open IntelliJ. Put it in the bottom here. So, what did we learn in the yesterday class? We had learned about the polymorphism and multiple inheritance, right? Now, let's look at another concept called encapsulation. Encapsulation. Sorry, this should not be the class. Instead, this should be the package. Right click, new package, encapsulation. So let's first write some notes here. Okay. Encapsulation. What is encapsulation? Hiding the data or data members is called as encapsulation. Very simple definition. Hiding the data members is called as the encapsulation. Okay, we'll learn programmatically what exactly it is, right? But in theory, simple definition, hiding the data or the data members is called as encapsulation. Okay, how do we achieve this? We can achieve this by using access modifiers or access specifiers. Using access modifiers or access specifiers. What are those access modifiers? There are four access modifiers or access specifiers. What are they? One is public, second one is protected, third one is default, and fourth one is private. These are the four access specifiers we have. These are the four access specifiers we have. Understanding of encapsulation. Understanding encapsulation requires inheritance. Requires understanding of inheritance. So yesterday we learned about the polymorphism. So similarly, polymorphism also needed inheritance to understand this. Similarly, even the encapsulation also needs the inheritance. Basically, both are interlinked. Inheritance, encapsulation, and inheritance and polymorphism are interlinked. Without inheritance, you cannot understand the encapsulation. Without inheritance, you cannot understand the polymorphism. Right? Cool. Let's write a simple program. Java class A public void test. Okay. Protected void test. I'll name it as test1. I'll just leave it as void test3. Okay. Next, private void test. Okay. So now we have created four different methods with all the access specifiers. We have four different access modifiers of the specifiers: public, protected, default, and private. So we have public here, we have protected here. This is default. When you don't specify any of these three, public, protected, and private, then it is a default. When you don't specify public, protected, and private, then it is a default. Okay, so for default access modifier, you don't have to write anything. You can just simply write as it is. You don't have to specify any of these three keywords: public, protected, or private. That is default. And the fourth one is private. All right, I'll just write one simple out. I am public. Yes out. I am protected. Yes out. I am default. Yes out. I am private. Okay, so now we have all the four possible methods with the four different access modifiers: public, protected, default, and private. Please remember the same order. There is a reason why I had written all these four in this order. Okay, public, protected, default, and private. Okay, there is a reason. I'll explain. I'll come back to it later. But whenever you are talking about the encapsulation, it is always recommended that you tell these four keywords in the same order. Okay, either you go from the top to bottom or bottom to up, anything is fine, but in the same order. If you start from the bottom, you should say private, default, protected, and public. If you start from the top, you should go public, protected, default, and private. But don't mix up randomly. Don't start with either protected or default. Uh, please don't mix up. Either you do it from the top to bottom or bottom to up. There is a meaning for that, which I'll cover it very soon. Now I'm going to create another class B. Right, just writing a main method here. This is the main method, psvm. I would like to call the methods that are available in class A. Okay, a1 equal to new A. Why I'm creating the object here? Why I am creating the object here?
Static method.
Because all the methods are non-static. So to call the non-static methods, I should use the object. So I am creating the object. A1 dot test1. I could call the method test1. Next, I would like to call the test2 method. A1 dot. When I just put a dot, automatically this pop-up is coming with all the available methods that can be called. A1 dot test2 is available. A1 dot test3 is available. A1 dot. Do you see the test 4? Do you see the test 4 here?
No.
Even if I write it manually also, it is still giving the compilation error. Whenever you see the red line, that means it is a compilation error. Why we are able to call the test 1, test 2, test 3 but not test 4? What is the reason? Because test 4 method is declared as a private method. So test 4 method is declared as a private method. So whatever the members that are declared as private, they cannot be accessed outside the class. They cannot be accessed outside the class. Public can be accessed anywhere. Protected can be accessed outside the classes, but it has some other extra restrictions, right? And the default methods also can be accessed outside the class, but it has its own restrictions. And we have the private method, whether it is a private method or the private variable. All the no private members can be accessed outside the class. No private members can be accessed outside the class. I can access these private methods only within the class. Let's say, for example, I write the main method here. I'll again create the object here. A1 equal to new A. This time I'll write A1 dot S1. See, when I just type in TE, it is showing all the four methods. But that is not the case when I do it in the class B. A1 dot test4. But here we are getting the error because private members cannot be accessed outside. If you just hover the mouse on this red line, it says the same message. Test4 has private access. Test4 has private access. Cannot be accessed outside the class. Any doubts here? So if I want to run this program, let's first run class A. What is the output that I will get? Test 1, test 2, test 3 and test 4. But when I run class B, right click on class B and then run. We had got only three methods that could be called. Only test 1, test 2 and test 3. Let's write another program. Create new class C. Private int I equal to 10. Next, private void test. Sort of I am private. PSVM. How can I access these two data members? One is by using the object reference C1 equal to new C1 dot. I'll try to print the value of I C1 dot I sort of C1 dot S1 C1 dot S1. Yeah. So if I run this program, I'll get the value of I, that is as 10, and then I am private. Any doubts here? Very simple. In the same program, I am just calling the private methods. So all the private members, that is either the variable or the method. So all of them can be accessed within the same class only. Within the same class only. Now, any question so far? Siddiq,
No, sir. No, sir.
clear? Everybody, Sumant?
Yes, sir.
Okay. I'll write one subclass for class D, class C. Okay. Subclass for class C. How can I create the subclass for class C?
Extends.
Extends
Extends.
C, right? Extends C. I'll write even the other methods also here. Okay. I'm just copy pasting here. I'll put all this. Okay. Now I'm extending the class C. So whenever we do extending C, what does it mean? What happens here? All the members of class C will be available in class D, right? All the members of class C will be available in class D, right? So if I just simply write PSVM and then try to P D1 equal to U D, right? So I'll write another variable here, just int j equal to 20. Okay. X out of d1 dot I, X out of d1 dot j. Next, d1 dot s1, d1 dot s2, d1 dot s3. Next, d1 dot s4. See, we cannot see the d1 dot test4 method is available, right? Usually when we do the inheritance, all the members should be available here. We are not getting it here. That is the reason it is showing the error. Similarly, same is the case for variable I. I is I is a private variable here, right? So this can be accessed only within the class C. right? This can be accessed only within the class C. But whether it is a subclass or it is some other class, the private members cannot be accessed. Private members cannot be accessed. Any doubts here? Private members will not be inherited. Right? Private members will not be inherited. Private members will not be inherited. Any doubts here? Any confusion?
No, sir.
Okay, cool. So this is all about the private. Whether you extend it or if you try to access directly, it doesn't matter. Private members can never be accessed outside the class. That is the bottom line. That's the bottom line. Private members can never be accessed outside the class. So this is all about private. Now we need to learn about default, protected, and public. So before we learn these three things, there is one small topic that we need to cover. That is required to understand these three things. That is the concept name is packages. The concept name is packages. I'll write the notes here itself. Packages. A package is a simple folder or directory in Java. Package is a simple folder or directory. Explicitly, I did not explain this concept, but we have been using this concept since day one. If you see here on the left hand side, all these are the packages. Com is one package. Within com, FinOps is one package. Within FinOps, App4 is one package. Within App4, abstract classes is one package. Encapsulation is one package. Global variables is one package. Inheritance is one package. Interfaces is one package. Multi-threading is one package. Non-static or instance members is one package. Polymorphism is one package, and static members is one package. If you see, this is just a folder, right? Even you can look at the icon also. This is just a folder. If you want to see how this hierarchy looks like in the file system, when I say file system, in the file explorer, right? I just right click here, right? I just right click here, reveal in. For me, this is the MacBook, so I am seeing the reveal in finder. But if you are using the Windows, you must see the option show in explorer or open in file explorer or show in file explorer. You might see one of those two options. Okay, that will open the file explorer like this. See, app 4, or I would like to open even at this level first, src, revealing finder. See, these are all the folders, you see it here, right? These are all the folders that you see here. Build is there, build.gradle is there, which is here, right? Gradle w is there, which is here. Gradle w.bat is there. You don't have to understand all these files, I'm just showing what is the content here, right? So, but our interest is to mainly go to SRC. Within SRC, what do we have? Main and test. So we see the two folders here, main and test. So we are interested in main. So see main here. You see two folders inside, that is Java and resources. So here again, if you go inside Java, you see this many folders. You will see first com, inside com, you will see the FinOps, inside FinOps, you will see the app 4, inside app 4, you will see these many files. All these blue icons are the folders or the packages that I had mentioned here, and the rest of the things, whichever is showing with the Java, those are all the Java files which are kept outside without any package. We are not putting them in the package. That's the reason they are directly being shown. And all other packages are being shown in the blue color. You can see all the packages here. These are called as the packages. Why do we use the packages? Why do we use the folders in the laptop, in the file system? That's the basic question, right? Simple question. You don't have to understand Java also for that. You don't have to have any understanding of anything to answer that question. Why do we use the folders or the directories in your system? Can anyone answer, please?
To store some data.
To store some data. Yes. What else?
Respective data in respective folders.
Exactly. Right. So respective data in the respective folders. That means we are doing some categorization there. Right. So I'll create some folder and I would like to keep only the corresponding data inside that folder. Similarly, if you look here, I had created so many packages. When I created the abstract classes, I had added only the programs that are relevant to abstract classes concept. I did not add anything else. When I created encapsulation package, I added only the programs that are relevant to encapsulation, nothing else. I did not mix it up. Similarly, I did with the global variables, inheritance, interfaces, multi-threading, non-static or instance members, polymorphism, or the static members. Right? A package is used to organize the classes. Organize the classes. Organize the classes. Can we create multiple files with the same name in a folder? I'm just asking in a simple normal folder. Can I create, can we create multiple files with the same name in a folder?
No, sir.
We cannot create it. It says file already exists, right? Yes or no? Yes or no?
Yes, sir, we can
What,
create.
what does it says when you try to create the same file again with the same name in the same folder?
Same file already
It
exists.
says
We
file is
want to
already,
replace it.
yeah, or you want to rename it something like that, right? Similarly, in the package, again the package is also a simple folder only, so we cannot create multiple Java classes with same name. We cannot create multiple Java classes with same name in same package. So package is completely the concept of folder. That's it, nothing else. But we need to understand this to understand the remaining three access modifiers. Okay, cool. So I would like to do, I'll create one package here. Now all these Java classes are lying outside randomly, right? So what I'll do is I'll create one package. I'll just try to put it them in that. Data types is the one concept that I had covered earlier. So all these examples can go there. Refactor, move classes, dot data types. So all those classes went to the data types package here. Similarly, I'll create another package where it says methods. I'll move all these methods examples to this. Refactor, move classes, methods. So all of them are moved to methods package here. Now I have these are the very basic first day classes, basic. I'll move all of them, right click, refactor, move classes, dot basic. So now it is very much clear. I did not move these two classes. There is a reason which we'll learn later. But all others now it is all clear, right? So each and every topic is in its respective package here. All right. Let me close everything and then open only our this thing. Where was that encapsulation, right? So encapsulation. Okay. I'll create. Did I create the packages here? I mean the packages as a name with another package. Package packages. Okay. Within the packages, I can create many other packages. How do I create? I had done many times. Now we are specifically learning about packages, right? So I'll create pack one. Okay. So inside, I'll create one more package, that is pack 2. Okay. So within packages I have pack 1 and pack 2. So in the pack 1 I am going to create a new class, that is class A, right? So here let's learn about void test. So I am default. So this is a default method or not, because I did not specify any access modifier here before void. So this is a default method, right? I'll create another class within the same pack, within the same package, that is pack 1, that is class B. Okay, I'm not doing any inheritance here, but I'll just write the main method, right? So how can I call the method test in class B? How can I call test method in class B?
Creating an object.
Yes, we need to create the object class a1 equal to new a, right? A1 dot test. Similarly, I write main method in the class A also. Again, I create same object a1 equal to new a. So here also I can call the method a1 dot test, right? So what did we do it here? We have created two classes A and B within the same package, that is pack 1. That is pack 1. So the default method, we can call this default method within the same class and also outside the class. If you remember the private methods, we could only call them within the same class but not outside the class. But here, the default members could be called outside the class also. Outside the class also. Let's create one class in pack 2. That is again class A. This A belongs to pack 2. Don't get confused, guys. This A belongs to pack 1. Okay? Unsplit. Now I'll write PSVM, or I would rather name it as Z. Okay. A1, A pack 1, A1 equal to new A, right? Now I want to call the method test A1 dot. Do you see the test method is coming up here? Do you see the test method coming up here in class Z? But here it is coming up in the class B. What is the difference here? What is the difference? The same test method we could call from class B, which is in pack 1, but the same test method we are not able to call in class Z, which is in pack 2. So, do you understand the logic here? The default methods can be accessed only within the same package, not only the same class but within the same package. Private is completely privated, the most secured. Private is the most secure. The next level openness is with the default members, that is within the package. Let the same package have any number of classes. So all the default members that can be accessed within the same package but not outside the package. Here pack 2 is a different package. That is the reason we cannot access the default members outside the package. Clear? Any doubts here? Default members cannot be called or accessed in outside the packages, outside the same package, outside the same package. If you just hover the mouse on this red line, you can see the same thing. Test is not public, cannot be accessed from outside the package. Clear? Can I move on? This is about default. Private members, please remember, private members can be accessed only within the class. Default members can be accessed within the class and within the same package. Now let's go to the protected. Protected is little more opened. Let's understand how opened it is. Now let's say, for example, anyways, I'll create class C here, which has the protected member, protected void test. S out of I am protected. Now I'll create another class, that is class D. ESVM C1 equal to new C and C1 dot test, because test was the protected member. So within the same package we could access it, right? Similarly, I'll create one new class here, Y, that is extending C. What is our class C here? What is the class C here? This is the class C that we are extending in class Y, but Y is in the package pack 2 and C is in the pack 1. Okay, I'll write ESVM Y1 equal to new Y1 dot test method. See, now the test method is protected method which is available in class C, but the class Y is in the different package. Still we are able to access the method which is in class C of pack 1 in the class Y of pack 2, because Y is the subclass of class C. This is the main difference. This is the main difference. I'll create another class here, class X. I'll not do the subclass here, but I'll write the main method class C, C1 equal to which C. We have so many C classes in different packages, so everyone it is showing, but I am interested in pack 1, so that's the reason I'll select pack 1. C1 equal to new C1 dot C. Here I am not able to call in the class X, right? We have the test method in class C which is available in pack 1. The same test method I am calling from class X and class Y. It is successful in class Y, but it is not successful in class X. Why? Because that is the definition of the protected. Protected data members can be accessed outside the package, but the class should be subclassed. The class should be the child class. The class should be the child class. Any confusion here? The same class C is the same test method I am trying to access from class X and class Y. In class X it is failed, but in class Y it is successful because Y is the subclass of class C. Y is the subclass of class C. That's the main thing. That's the definition that we need to learn here. Protected members can be accessed outside the package but within subclasses. Anyways, within the same package you can access them. Whether, see, if you see here, in the class D you can access, in the class C you can access. For example, if you want to create another class with class E which is extending C, there also you can access, because that is within the package. Protected members can be accessed within the same package, and in addition to that, in all the subclasses of different package, in addition to the same package, in all the subclasses of the different package. See, step by step. First we learnt about the private, where we can access the members only within the class. Next we learnt about the default. So default members can be accessed only within the same package. Now it is protected. Protected is within the same class, within the same package, and outside the package but subclasses. That is the condition. Outside the package but with the condition. Clear? Any doubts here? You need to do a lot of practice here. It might be slightly confusing initially, but if you do practice right, it is a very very simple concept. We are learning level by level. First is the most secured one, that is private, only within the class. The next level is default, that is within the packages. Next level is protected, that means packages plus subclasses in the outside of the packages. That's how you need to remember. Clear? Can I move to the public? Guys, any doubts, please? Please let me know if I need to repeat. Siddiq,
Yes, sir.
clear? Am I going
Yes.
fast?
No, no, it is okay, sir.
Clear, right?
Yes,
If I
sir,
am
clear.
going fast, anybody let me know, please. I'll go little slow. No point in going faster when you don't understand anything. I don't prefer that. Can I move to public now? Cool. We'll move to the public. I'll create another class E in the pack 1. Right? The same pack 1, I'm creating the class E. So I'll do public void test. That's out of I am public. Now I'll try to access this in the same class E1 equal to new E1 dot test. So within the same class it was accessible, right? Now I'll create another class F ESVM E1 equal to new E, right? E1 dot test. So here also I am able to access, no issues. I'll create a subclass to it, FG extends E, right? ESVM E1 equal to new E, right? E1 dot test. So this is also acceptable. Similarly, when we do the extends, obviously all the members of class E will be available in class G. Let's try to create the object for G and then try to access it. G1 dot test. See, the subclass also it is accessible. Now let's look at the outside the package. Outside the package, class XYZ. What comes before XYZ? W, right? So here I'll try to access the class E. There are many classes in different packages, but I am interested in pack 1. That is the reason I am selecting that. E1 equal to new E. E1 dot, should write the main method, right? E E1 equal to new E. E1 dot test. So outside the package also I could access without extending the class, without extending. See the difference. Default the protected members I could access only when I extend the class, but the public members I could access even without extending the class, without the subclass. I'll create another class with extending V extends E. Which E we are extending? Pack 1. Yes, VM. So obviously the test one method is available in class B and class E because we are extending it from here. So first I'll try to access through E, E1 equal to new E, E1 dot test. Now I'll create with the B, V1 equal to new B, V1 dot test. So what did we understand now? What did we understand now? We had created the public method in the class E. We had created public method in class E. We could access in the same class. We could access in the same package in the different class. We could access in the subclass within the same package, right? And then we could access in the outside of the package where it is not subclassed, and we could access outside of the package where it is subclassed. W is not subclassed and V is subclassed, right? So that means the public members can be accessed anywhere. You can clearly and simply say that public members can be accessed anywhere within the application. This is all the application, right? This is the entire application. This is the entire application code. You create any methods in any package and you call them in any package in any class. They are accessible. Public is completely public, right? Simple. Try to relate with the simple English words. Public is entire public. Protected is slightly restricted, right? Where it can be accessed only within the subclasses of outside the package. And the default is little more restricted, and private is completely restricted. This is the reason I was saying you need to remember these four access modifiers, either top to bottom or bottom to up, right? So when you go from top to bottom, the restriction is going up. It is one by one, it is getting more and more restricted. When you go from top to bottom, more and more restricted. But when you come from bottom to top, it is widened. I could say it is widened, or the restriction is reducing level by level. Restriction is reducing level by level. Any confusion here, guys, in this? Clear? This is what protected, right? Protected members cannot be accessed outside the package without subclass. That is the reason we are getting the error here. I just commented it out, but if I uncomment, this is the message. I will create one notes here. Where was I writing the notes earlier? In the encapsulation. Okay, this is not required. I'm sorry. I'll delete it. So let's put it in a Excel file where it is even more easy for you to understand. Let's stop. I am opening a Excel file, right? Public, protected, default, private. Right? I'm not sure whether you can see this or not. Can you see this or it is too small?
Too small.
Why I am not able to make it bigger? It is not responding. Okay, I'll do it through some online editor. Yeah, should be able to do it now. Right. Public, protected, default, and private. So what are the various factors? Same class, same package, different package, different package without subclass, different package with subclass. These are the various factors, right, that had come while learning. So public members can be accessed within the same class.
Yes.
Yes. Within the same package?
Everywhere.
Yeah, everywhere, right? That's what I said, anywhere. So yes, yes, yes. Now let's go to protected. So protected members can be accessed within the same class. Protected members can be accessed within the same package. Yes or no?
Yes.
Yes. Same package?
Yes.
Yes. Different package without subclass?
No.
No. Different package with subclass?
Yes.
Yes. Now default. Default members can be accessed within the same class?
Yes.
Same package?
Yes.
Yes.
Different package without subclass?
No.
Different package with subclass?
No.
Sumant, was that you
No.
were saying so far, right?
Yes, sir.
Yeah. Yes or no?
No.
No. Now, private members, same class,
Yes.
Yes.
same package,
No.
No.
different package without subclass,
No.
No.
different package
No.
with subclass,
No.
right? Probably I'll move this line to here. For readability purpose, it will be even more easier for you to remember, right? So if you remember this table, right, you got the encapsulation in your mind. If you remember this, you got the encapsulation right. See, public, it can be accessed everywhere. Protected, it can be accessed everywhere except different package without subclass. And default, it can be accessed only within the class, within the package, not outside the package, irrespective of it is a subclass or non-subclass. And the private, only within the same class. So if you go from right to left, the restriction is opening or getting closed. From left to right, public, protected, default, private. Here it is more wider, right? Here it is more restricted, private is more restricted, this is more open. When you go from right to left, this is more restricted to most open, right? So this also might be a very good important interview question. So they might ask, what is the most restricted access modifier? Most restricted access modifier, what is the answer?
Private.
Private is the most restricted access modifier, right? What is the least restricted access modifier? What is the least
Public.
restricted of access modifier? Public is the least access, least restricted access modifier. Clear, guys? Clear? Any doubts, please? Yes or no? Any doubts, please? Guys, please respond. Anybody has any doubts?
No doubt.
No doubt, sir.
That's Suman Siddiq.
No, sir.
I'm taking this screenshot and putting it in our code base itself. Right, this is not the one. Sorry. Oh, right, I'll put this image here. Paste. Right, you have it here. So if you know this table, you got the encapsulation in your hand. Okay, I'll stop it here. Right, so far we had covered basically there are four whoops concepts. Four whoops concepts. When I say whoops, it is object oriented programming concepts, right? So we had covered all the four whoops concepts, that is encapsulation, polymorphism, inheritance, and abstraction, right? So abstraction has been covered with the basic examples, basic classes only. Each and every class that we write in Java is a abstraction. So there is no separate thing to explain. So whatever the classes you write in Java, all of them comes under abstraction. Don't get confused abstraction with abstract classes, guys. This is a very common mistake. I think 90% of the people, or maybe even 95% of the people, does this mistake. When somebody asks interview question about abstraction in the interviews, everybody I had seen in my career, 99% of the people talks about abstract classes. Abstract classes is different and abstraction is different. Don't get confused, don't do that mistake, please. Abstract classes is different and abstraction is different. Whatever the classes you write in Java is a abstraction, but abstract classes, it has its own meaning, right? That is a different thing. Don't do that mistake. I had seen 99% of the people doing that mistake in the interviews. So we had learned abstraction, encapsulation, inheritance, and polymorphism, the four whoops concepts. If you had understood these four whoops concepts, the entire Java is kind of a cakewalk for you. If any of you have any questions, I know there are the new joiners, they did not join from the starting. So I'm going to cover the previous topics anyways, right? But for those who ever joined from the first class, right? The going forward, the entire Java is depending on these four concepts. If you have the understanding of these four hoops concepts, that's all. You can understand everything in Java. You can learn anything easily. But if you could not understand any of these four topics, you cannot understand the subsequent topics. The entire Java is depending on these four concepts. Cool, guys. Any questions? Last call.
No, sir.
Great.
No.
So I would suggest you to please do the practice as much as possible. See, I had done 38 files today. What did we learn today? Encapsulation. Before that, packages. For the old students, For the old students, I had given you the access to the GitHub repo, right? You can see all the examples and do the practice. It is not responding. No, why it is not responding? Okay, I'll see this. I'll try to commit these files later, right? So old students, you have the GitHub link. Please follow the GitHub link. All the programs are uploaded there, right? Please refer them, do the practice as much as possible. If you can do 10 programs for each program, that's when you understand the things much better, right? So I don't even say that only one program one practice. No, one program 10 programs practice, 1 is to 10. Then only you can understand the things much better. You can remember the things in your brain, otherwise it will be lost. All right guys, if no questions, I'm closing it now. Thank you everyone, have a nice day. Bye.